Question 11. Well, first thing that I've done here is just draw myself a little diagram just so I can appreciate what's going on. So we've got height and we've got distance. So an arrow is fired and then it comes down. There we are. Now, when the distance is 0, I can tell that this value here must be 1.8. Now the first question says find the horizontal distance travelled by the arrow as given by the model. So in other words, it wants this point down here. So when the height is equal to 0. So 0 equals 1.8 plus 0.4d minus 0.002d squared. And remember, d has to be more than or equal to 0. So let's just use the quadratic formula. So we've got a, we've got b, we've got c. So a is minus 0.002. I'm not going to do this bit for you, but just sub in these values into quadratic formula. And what you should get is d is equal to minus 4.4, or d is equal to 204 meters. Now clearly it cannot be that one. Remember, d has to be more than or equal to 0. So the answer is 204 meters. Part B. With reference to the model, interpret the significance of the constant 1.8 in the formula. Well, we've already really said that. It's the initial height. It's the initial height of the arrow, where it's fired from. Right, now part C. So basically we just need to go and complete the square. That's all. So if you think about completing the square, what you do is you take out our constant of minus 0.002. And this is, so take like that there. Now if I were to 0.4 divided by minus 0.002 is 200, well minus 200 d, and then we've still got on the end we can have a plus 1.8, right? So just remember, you complete the square, it's going to be d minus 100 squared, and I need to take away the excess, so that'll be 100 squared, so 4 zeros, and then you're going to multiply that by, there we go, 0.002, and don't forget we've got a plus 1.8 at the end. So let's tidy all of this up. So what have we got? We've got minus 0.002 d minus 100 squared. This times this is plus 20, and then plus the 1.8. Now let's get it into the same form. Let's get rid of that, it's confusing, the 3 marks there. So let's get it into the same form, add these two together as what they actually want just here. So that's going to be 21.8, so that's the A. Then we've got take away 0.002 d minus 100 squared. There you go, look. So you've got the A, you've got the B, and you've got the C. Now, next part of the question. So we've got an adapted model. Now the difference of these, it's all the same, apart from that's 2.1, and the first one was 1.8. Everything else is the same. So in other words, it's just plus 0.3. So how's that going to make a difference? Well, the maximum height of the arrow above the ground. Well, let's work out the maximum height of the arrow here. Well, that would be when this bit here is 0. So the maximum height would be 21.8, but we need to add that 0.3. So add the 0.3. course, that equals 22.1. And that's meters. And then the last bit, the horizontal distance from the arch of the arrow when it's at its maximum height. Well, that's going to be the same as up here. So that's when these 100. So 100 meters. It's going to be exactly the same as what we just did a second ago.